Hey YouTube, what's up? Thanks for tuning in. Part 3 of my Capo CUB1 build. Only a little bit of progress, part of the frame build. And in this video I will show you the 2-speed gear mechanism, and I will search for a motor that fits to my Capo CUB1. But first I want to show you the differential gears of the axles, because I didn't show those in my last video. I also found that I maybe would have forgotten to lubricate the differentials, so the small gears sitting inside the gearbox. But this was not the fact. However, I disassembled the axles again, and this time I also tried to disassemble the central gearbox of the axle. There are two small E-clips or C-clips to remove. They sit on this position here, and the other one sits here. And after this, first I had to remove this part, which is mounted by a pin and held by a pin. I thought I would be able to remove those two parts of the gear, but I did not succeed in taking off this upper part, and this has to be removed. I even tried a hammer, but there is some resistance and I do not want to destroy anything. I tried a little bit, but it didn't come out, and so I stopped this because it's not necessary, because here I can take a look inside those differential gears and I could verify that they are very well lubricated. I pressed enough grease inside. Maybe you can see the small gears of the diff inside. So, because it didn't work so easy, I stopped this and take it as it is and reassemble the axle again, and everything works fine and everything is nicely lubricated. E-clips, C-clips, always a little bit of a pain. We will see more of those later in this video. So axle assembled again. After the first or second time this is much easier, so not a big problem, everything works fine. And following the manual, then I first mounted this first part of the frame, which was super easy. Of course I used blue Loctite, and Capo uses Phillips head screws. Those flat countersunk screws used to mount those plates here and here, they are Phillips head and they are magnetic. And for the shock mounts, those are 1.6 by 4 millimeter Phillips head screws, and for mounting the shocks they use hex screws, also 1.6 by 5 millimeter. Looks awesome, no problem, and awesome quality. And the next part was assembling the gearbox, and there I did already have a problem because I didn't buy the Capo motor. This is the pinion gear, which comes to the motor or to the shaft of the motor with gearbox that is used, and this needs a 3 millimeter shaft, and all the small motors I do not have a 3 millimeter shaft. They usually 180, 130 motors do have 1.5 millimeter or 2 millimeter shafts. So I do not have a motor that fits, but tiny Orlando motors, and I probably for testing purposes will use an Orlando motor now, because it was super difficult to find proper motors. We'll need a motor with 16 millimeter diameter of this front gearbox, or 15.5 millimeter. And those motors, a user of ASIC Roller forum showed me those motors. They are called 16 GA motors, so 16 gear motors, and it seems to be impossible to find such motors here locally. I searched for hours, I couldn't find any, some on Amazon, but also sold from China and sometimes not delivered to Austria. However, I had to search in China on Banggood and on AliExpress and also on eBay to find such motors. I also found some in the United States, but this doesn't help me. I ordered 3 of those motors, 2 are already shipped and hope they will arrive soon. What motor I ordered and what RPMs those motors do have, I will explain in the end of this video, the search for the right motor. But first, let's check this 2-speed shifting mechanism, which is quite awesome in my eyes. So there are 2 gears on the counterpart of the pinion. The pinion gears do have 30 teeth, the large pinion, and 21 teeth, the small one. And the counterparts, those 2 pinions, do have 32 teeth, that's the large one for the first gear, slow gear, and 23 teeth for the second high gear. And the way this shifting mechanism works is, for me, quite new. I do have quite a couple of trucks with 2-speed transmission, but in all those the gears move. In this truck, in the Capo, it's different. Mounting those is not very difficult. However, again, E-clips, C-clips, 2 larger ones here, not so difficult, still nasty, but on the shifting arm here you do have to mount 2 small springs and 2 1.5 millimeter E-clips, C-clips. Not the stuff I like most, as most of you probably. This shifting arm will be connected to the servos, of course, and inserts to this center gear, what is not really a gear. And this center gear is held in position to the axle by a pin. So it cannot turn, it cannot rotate, but it can move, be shifted. And the unique thing, at least for me, I didn't know this before, of this shifting mechanism, the 2 gears do not sit firmly on the axle. They can rotate, and only this center mechanism can move and rotates with the axle, and it has 4 of those, I don't know how to call this, teeth, and those insert to the corresponding gears. So you can see this here, 4 openings for this center part to insert its teeth. So if the center part sits on the left side and is pressed to the left side, the large gear will rotate and the small gear, what is second gear, will spin freely, and only the large gear will rotate with the motor. And if the shifting mechanism moves this center part to the right side, then the small gear will rotate with the motor, so with the pinion gear, and the large gear will spin freely. Quite unique for me, don't know if that's usual, didn't see it, looks quite awesome so far. So that's the only gear reduction that will happen in the center transmission. In second gear, in fast gear, the 30-tooth pinion rotates the small pinion, and therefore it's a factor of 1.3. So one rotation of the motor pinion will cause 1.3 rotations of the small pinion and then of the drive shaft. And the small gear on the pinion with 21 teeth will rotate the large gear on the counterpart with 32 teeth. So that's a factor of 0.66, what means 1.3 versus 0.65 or 66. The second gear is nearly exactly 2 times as fast as the first gear of the Capo CUB1. What's quite nice. In the center gearbox, there are 2, a small and a large one. There is no further reduction. There are 3 more small gears in a second gearbox. Those 2 have 18 teeth each, so that's only transmission but no reduction. Speed of axles or rotation will not change in this anymore. There is only one more reduction, and that's in the axles. The bevel gears. The large bevel gear sitting here does have 24 teeth, and the small one, this one, does only have 12 teeth. So that's exactly a factor of 2, what means one rotation of the drive shaft and the small bevel gear will cause only 0.5 rotations of the axle and then the tire. That's the way the stuff sits later on in a nice gearbox, aluminium, and here the motor sits on that plate, and I will probably mount the Orlando motor for the next video to be able to do some tests. Shift test. And I was searching for a correct motor because I didn't know there's not a lot of information about the Capo CUB motor. It's labeled 22000, so 22,000 kV. I hardly can believe this. However, I calculated how much turns by the motor or by the gearbox coming out of the motor I will need to get the proper speed, the speed I want on 2S or even on 3S. And I hope I didn't do any miscalculation, and I will explain this to you now, and you please follow me and correct me if I was wrong or do have made some mistakes or errors. What do we want, or what do I want? I want a speed on 2S or on 8 volts of about 6 kilometers per hour, 6 kph in second gear. That's quite okay, I think, for such a small truck on high speed. And if I go 3S, it will be much faster then. And this would also mean it will do about 3 kph on the first gear. 6 kph are about 3.7 miles per hour. 6 kph, 6 kilometers per hour, are 6,000 meters per hour. All the motors that are sold with gearbox, they show in their specifications the rounds per minute. So I want 6,000 meters per hour, and this means divided by 60, 100 meters per minute. I want the car to do 100 meters per minute. The tires to have a diameter of 52 millimeters about. This means the circumference C is about 163 millimeters. That's 163 millimeters, 16.3 centimeters, and 0.16 meter. So one rotation of the tire is 0.16 meter. I want the car to go 100 meters a minute. This means the tires have to rotate 625 times to make those 100 meters. 625 turns per minute of the tire will make the car go about 6 kph. So what does the drive shaft need? What rotation? Because we have this 1 to 2, this means the drive shaft has to turn twice as fast. This means the drive shaft has to turn 1250 times per minute to make the tires rotate 625 rounds per minute and the car to go 6 kph, 3.7 miles per hour. So that's what in the axles happens. And then we have to go to the central transmission with reduction 2 and calculate this. So if the drive shaft has to rotate 1250 times per minute, this means in second gear, the factor in second gear is 1.3, so one rotation of the large pinion will cause 1.3 rotations of the small pinion and the drive shaft. This means the motor or the shaft coming out of the gearbox of the motor has to rotate 958 times to make the car go 6 kilometers per hour in second gear and half of this in first gear. And all this is calculated for 8 volt, what's about a full 2S LiPo. So 8.4 volts, you will be soon at 8 volts, 7.9, 7.8. I use 8 volts for a 2S LiPo and 12 volts for a 3S LiPo in my calculations. And all those gear motors give their specifications in rounds per minute for either 6 volts or most 12 volts. And if a gear motor does have 1000 RPM at 12 volts, this means it does have 2/3 of this at 8 volts. So 12 minus 4 is 8. 3 times 4 is 12, 66.6%. And this means a 1000 RPM motor at 12 volt should give about 666 RPMs at 8 volt. So I was searching for a motor with more than 1000 RPM. What is not that easy either. Most of those are very slow motors, but you will find some few with 1000, 1500. 1500 would be nice because 1500 RPMs at 12 volts, what's the specification of the motor, would give 1000 exactly at 8 volts, and that's what I was searching for. So I ordered one of those motors cheap from AliExpress with 1500 rounds per minute specification at 12 volt. I'm not sure it will fit with the top end, and I ordered 2 more from Bango. They even have already been shipped the night I've ordered them with about 900 and 850 RPMs at 12 volt. I will see later on then if this is not enough. Then I can switch to 3S, what I intend to do anyway. And on 3S, this should be quite okay with 900 rounds per minute, but I will see. This will be a matter of testing. However, I want to test this. I do not want to buy the Capo motor with ESC. If it would have been sold without ESC, maybe I would have ordered it, but not. I will use much better ESCs. And now I will continue my build following the manual, and in the next video I will hopefully be able to show the shifting gear mechanisms and a little bit more of the frame and so on. That's it for this video, guys. Thanks for watching. See you in the next video. I'll be